Okay, cardinality. So often we're interested in the number of items in a set. So if you we'll go way back, I just want to make sure we get the distinction here. Way back to the first lesson there, we were looking at, ordering the things in a set. So we'd say, okay, A was, red, green, blue, B was red, yellow, orange, right? So now cardinality, all we're really looking at here is how many things are in the set. So the cardinality, let's say of this example, just would have been 3. And the cardinality of this one also would have been 3 because there's just 3 things in it, right? So that's pretty much the gist of it, but we can do some things with this, right? So we can do a little math with this. So yeah, cardinality of a set is often notated as, in 30-2, it's usually actually notated as the second one. So you can read this as the number of elements in set A, and then you'd say is equal to, and then like an actual number. So you'd be like 3, right? Notice how that's different than before. Before that was something like A is equal to squiggly bracket, and then you'd have like 5, comma, 6, comma, 9, comma, 11, right? So that it's a different thing. This is actually, the original was showing the elements in the set, and then the cardinality, when it's written like N bracket A, that's number of elements in the set. So in this case, that shouldn't be 3, that would be 4, right? 1, 2, 3, 4 things in that set. Okay? So if we look at this example, we can see it says let set A equal those numbers and set B equal those numbers. What's the cardinality of B? Okay, well, the cardinality of B, so we could say, N bracket B, so the number of elements in B is equal to, we'll just count the things in B, so there's 4. Okay, the cardinality of A union B, so you can write it like this. You can say, okay, the number of elements in A union B is equal to, and then that's it. Remember, union just means like together, right? So it's or. So in that case, A union B would have been 1, 2, 3, 4, 5, 6, 8, right? Those are just, if it shows up in either, that's part of the union of the set, right? Okay, so then, sorry, did I count 8 there? Should have been 7. Okay, so then the answer would be 7. There's just 7 elements in that set, right? Okay, the cardinality of A intersection B. Well, intersections where they cross. The intersection would just be those numbers. So you'd say A, or the number of elements in A intersection B is just equal to 3. Okay, I'm going to move down a little bit. I'm going to start on 14. This is a very typical question. So these questions are a bit of a puzzle, right? They give us some info and we need to kind of solve the missing part of it, right? So pretend we don't have this yet. So it says, a survey asks 200 people, what beverage do you drink in the morning? And offers choices. All right, so the options could be tea, coffee only, or tea only, coffee only, or both coffee and tea. So suppose 20 report tea only, 80 report coffee only, and 40 report both. Okay, how many people drink tea in the morning? And then how many people drink neither tea nor coffee? Okay, so sorry guys, every time I start talking, I get like there's a drill going in the background here. So okay, so suppose 20 report tea only. Okay, I found a different room. I think we're good now. All right, so where was I at? So suppose 20 report tea only, 80 report coffee only, and 40 report both. Okay, so now it says how many people drink tea in the morning and how many people drink neither tea nor coffee. Okay, so the idea here, well, let's use our Venn diagram to start to piece this thing together, right? So what we're gonna do is we're gonna write down our universal set first. So what's the universal set? Well, the universal set is gonna be all of the people, right? The survey asked 200 people. So we are going to put a 200 up in the top corner to remind ourselves that is the universal set. Okay, and you might want to say like U is equal to or something. So you remind yourself that's the total. Okay, Now, just be careful. So what we did here is we wrote down that 20 report T only, right? So that's like the blue area here, and that's just this area, right? That's the moon shape, because it's just the reported T only, right? It doesn't include this, so it doesn't include that part of it. It's people who only drank tea. Okay, the 80, the same thing, but on the other side, 80 was coffee only, so that's only that moon shape. Okay, and then 40 was where they overlap, right? That's the intersection of the two, because that's both. Okay, that's and. So same thing. All right, so now what's it asking us is, it says how many people drink just tea in the morning. So we have to know what we're looking for here. So tea in the morning isn't just 20, right? Because tea in the morning is going to be both of those, right? Tea in the morning means that they drink tea or they drink coffee, right? They could do either or, but they drink tea in the morning. So this one's not going to be 20, and that's where kids get mixed up quite often. It's going to be 20 and 40 together. We got to add that up to get 60. So we can say the number of elements. Oh, sorry. Number of elements for, let's say, T is equal to 40 plus 20, so 60. All right. Now, yeah, these ones have already been labeled for us, but if they don't, when you're making it, yeah, you'd write like a T or a C or something above them so that we can remind ourselves what we're looking at there. Okay. Next one. So now it says how many people drink neither tea or coffee. Okay, so what we got to do here, right, is if there was 200 people surveyed, then the amount of people who drink neither, I'm really talking about like the area outside the circles, right? So if 200 is like the whole thing, then outside the circles is going to be my neither. So in that case, the number of people who drink neither tea nor coffee is just going to be 200. So just kind of what we have here, right? 200 minus 20 minus 80 minus 40, right? Just subtracting these numbers out, because what you're left with would be 60. So 60, just by coincidence, it's also 60. Okay, and then I write neither down in the bottom right corner. All right, next one. Okay, next one. So this one says a survey asked which online services have you used in the last month? Okay, so it could be Twitter, Facebook, or have you used both? So what we want to do on any of these to get our bearings, let's draw our picture. So we're going to make a square and two circles to make a Venn diagram. Okay. I'm going to put T for Twitter and F for Facebook to like label my circles there. All right, and then we're going to start kind of making sense of the numbers that they're going to give us. So it says the results show 40% of those surveyed have used Twitter. All right, so what does that mean? So if I'm going to start putting my numbers into this thing, then you might say, okay, 40%. So I'll put a 40 there. But where does it attach to, right? In the last example, the 40, right, when I put it there, that actually meant like that half moon shape, right? That was like half of that thing. Where what I want is 40% of people just use Twitter, like the whole circle itself. So typically what I do to kind of like keep myself from getting confused here is I draw like a little bracket on the outside showing that this is 40. Okay, so this kind of reminds myself that the whole circle itself, right, all of it is 40. Okay, so then Twitter, 70%. Sorry, 70% have used Facebook, my bad. So then the same thing, I'll say, okay, this is 70%. I'm not writing the percents for now, but what I should do too, our universal set, because we're talking about percents, would just be 100%. So I know that That's all we have, right? Just is 100. Okay, so first thing you might notice, 70 plus 40 is actually already over 100. So how does this make any sense? Well, it makes sense because there's some overlap, right? Like it still will work out in the end. I just don't know how many are just Twitter overlapped and just Facebook. Like I don't know those numbers yet. Oop. But that's what we're going to be able to figure out. So, okay, let's look at what we're looking for here. So now it says, and 20% have used both. Sorry, so we do have that one. So 20% I can put right in the middle because that's where they overlap. That's their intersection, right? Okay, so now the question's saying, how many people have used neither Twitter or Facebook? So I'm looking for this, right? I'm looking for everything not in those circles. Okay, so just to figure out where I want to get here, what I want to do is go 100 minus the union of those circles, right? I want to go 100 minus all of that. But I don't know what all of that is because it's kind of like distributed kind of funny, right? I don't know what this is and I don't know what this is, right? Okay, so what I would do here, or what we can do, little tricks here, is we can do like make it like a little puzzle. So if I know that 40 is the entire circle, okay, and 20 is the overlap portion, then I should be able to just go 40 minus 20 to get what's left here. So this should also just be 20. So, okay, so I pieced that part of it together. Okay, now if I look over on this one, so same type of thing. So if this is 70 and this is 20, then you can probably do this one in your head. 70 minus 20, this must be 50. Okay, so then we're doing pretty good. So now I can actually just add those up because all of those added together would give me the union of those. It would give me everything. Okay, so all we got to do to find the union there. So then here we can even write it out properly. We could say the number of elements in T union F is equal to, and that would just be 20 plus 20 plus 50. Okay, so that's going to be 90. Okay, so why is that helpful? Is because we're looking for everything but that, right? So if that's what the union is, we're looking for everything but that. So lastly, we can say the number of elements in T union F prime, right? Because that's all that means. It means everything in T union F, actually everything not in T union F is going to be equal to, and then that will just be our universal set of 100 minus our union, so 90. So that's just going to be 10. Okay, so the answer there would just be 10. Okay, so that's how you kind of figure these things out using a picture. There is another way too, and this is on your formula sheet as well. And it's written like this, Cardinality Properties, okay? Where we could have solved this thing a little bit different. And I'm just gonna sketch it out again here actually. Okay, so another way we could have done this is, well, what if we added up a whole, like we had the whole circle, right? So here, I'll write down what that was again too. So that was 40, sorry. And this one was 70. All right, so now what we can do, we can actually figure out what the union of those things are using this equation. It's actually using this equation here. So the number, and this is saying the number of elements in A union B, so that's what I just drew here, the number of elements in the whole thing is equal to the number of elements in just A, so that'd be 40, plus the number of elements in B, so 70, and then minus the intersection, so minus the middle. So let's think about why that makes sense. If you had, I'm going to separate these circles for a second. So if this circle is 40, and this circle is 70, right? And then I bring those two closer together, right? I actually overlap them. Well, so if I add up 40 and add up 70, and then overlap them. What I can do is you end up getting these things, yeah, so they go like that. But then the overlap, if you think about it, what happens is we end up counting that thing twice. We count the middle area 2 times, right? So that's why we end up with a number above 100 right off the bat, because we counted the middle twice, right? So all we have to do is just subtract the middle, and that's what we're doing here. That's why we're subtracting the middle, subtracting the intersection. Okay, so let's show that we would have got the same answer just by using our formula. So we'll say the number of elements in, here I'll just write the whole thing again, number of elements in A union B, here, actually I'll do T and F. T union F is equal to the number of elements in T plus the number of elements in F minus the number of elements in T intersection F, right, the middle. So let's actually just put what those numbers are. So there, the number of elements in T union F is equal to, so the number of elements in T was 40, right? That was just the whole circle. So 40 plus 70 minus, and the middle, I didn't write it down that time, but the middle was 20. So minus 20. Okay, so the number of elements in T union F is equal to 90. Okay, so remember what we were looking for though. That was the intersection, but the question was saying everything not in, or sorry, that was the union. But the question was saying what's everything not in the union, right? How many people are neither Twitter or Facebook? So in the end, we'll say, okay, then the number of elements in T union F prime will be 100 minus 90, so 10. Everything but the 90. Okay, so that's how we solve that one. And then let me just kind of like explain this one too, because this next one isn't really that confusing. This is saying the number of elements in A prime, or not A, is equal to the number of elements in the universal set minus the number of elements in A. We've done that a bunch of times now, right? That's just saying that, you know, if you had circle A, then the number of elements in not A is going to be your universal set. Let's say that was like 100 minus A. That's going to give you everything outside the set. So that's all that one's saying. Okay, and then this part here, notice they're just saying that the other thing we can do here is we could rearrange this equation. So typically we use it this way, right, in 30-2. But we could also just rearrange this a little bit, where if we subtracted this from both sides, right, brought this over to the other side and brought this over to the other side, made a negative, then the equation can be written in this form, where the number of elements in A intersection B is equal to number of elements in A plus number of elements in B minus the number of elements in A union B. All right. All right, example 16. So 50 students were surveyed and asked if they were taking social science, humanities, or natural science. So of course the next quarter. So here's a bunch of numbers, right? So it tells us 21 were taking social science course, 19 were taking natural science, 7 were taking social science and natural science, 3 were taking all 3, right? So a bunch of information. So these ones get a little bit more complicated because now we've got 3 circles that we gotta get figured out here, right? So here, you know what? I'm gonna make my own here, my own circle, my own Venn diagram here too. Okay, so let's try to piece this thing together. Actually, you know what? I will use the one they have here too. So it says how many students are only taking a social science course. Okay, so first off, let's figure out what that means. So if this is my social science course, right? If that whole circle is social science course, then in the end, what I got to do is I got to figure out what like A, B, E, and D are, right? I got to like piece this whole thing together. And we're going to do that by, you know, putting these numbers in where they go, which is the hard part, right? That figuring out where those numbers go, and then maybe adding or subtracting, you know, to get what we need there. So let's start filling this thing in. So it says 21, we're taking a social science course. Okay, so, oh, sorry, my bad. How many students are only taking social science course? So we're just looking for A, right? That's the one we want in the end there, okay? So 21, we're taking a social science course. So again, what I do is I make my little bracket here on the outside to show myself that the entire circle, right? Because we're taking just means it could be any of them, is 21, right? So the whole circle is 21. Okay. 19, we're taking a natural science course. So natural science course, we've got 19. 7, we're taking social science and natural science. Okay, so what does that mean? So social science and natural science. Okay, so what I'm doing here is I'm looking at social sciences, that circle, natural sciences, that circle. Okay, so if you want to circle them too like this, right? Now, when I say and is the overlap, right? That's the intersection. So that's that right there. That's the whole thing. So 7, we're taking those two together. Okay, we can like ignore the C at this part because it didn't even, or sorry, the humanities, because we didn't even care about that in this part of it. Okay, so let's write 7 and maybe write it more toward like the middle and maybe like even overlapping to remind yourself that it's actually both those spots. Okay, 3, we're taking all 3. Okay, so 3, we're taking all 3, so that's going to be in the middle. So 3. Yeah, so that's where all 3 of them overlap. Can you see that that would be like right in that one? Okay, 26, we're taking a humanities course. So that'll be like the others here where it was on the outside. So 26. And 9, we're taking social studies and humanity, or social sciences and humanities. So that will be both of these, right? That's the and of those two. Okay, so that'd be 9. Overlapping like on both of those. Okay, 10, we're taking humanities and natural science. Okay, so that's going to be humanities, natural science. This is the overlap there now, right? So that'd be 10. And then 7, we're taking none. So that'll be 7 down here. And then 50 students was our universal set. So I should have wrote that down at the beginning. Okay, so now we have it all down. We have our goal in mind. We want to figure out how many students only took social sciences. So A is what we're after here. So let's start to piece this thing together. Okay, so if I know that all of social sciences was 21, right, that whole yellow circle around the outside, then what I just have to do is, you know, this 7 and this 9, right, those were actually like D and E together. That's that section together, and 9 was B and E together. So all we got to do, if I want to figure out like B and D, then, oops, sorry. Then all I got to do, like in this section, is I'm going to go to find D. I'll say D in this case is just going to be 7 minus 3, right? D would be equal to 4, right? Because if 7 is the whole, both of those together, if I subtract 3, then I'm going to end up with just D. So D is equal to 4. Okay, so what I can do at this point too, if you want to, is I can actually like erase the 7 if you want, or just write it a little bit different. Just don't get confused. And I know now that D is 4. We're going to do the same thing with B. So B is going to be equal to 9 minus 3. Okay, so B is 6. Okay. So now this might not be too bad now, right? Because if I know that this whole circle is 21, and this part's 4, this part's 3, and this part's 6, and I want everything but those 3, right? I want everything just in that section there. Then really all I got to do is go, well, here I'll say A will just be 21 minus those numbers, right? Minus 4, minus 3, and minus 6. So A is equal to 8. There you go. Okay, so that's pretty much the gist of it. So give this one a try. I might make a video of this one a little bit later too, just to see how that goes. But other than that, yeah, just go for the homework questions.